Welcome to this video. Today, in this video, we will understand arithmetic progression and its components. Look at this picture. Can you see any pattern here? Many objects in nature around us follow a certain pattern. We can see several patterns around us or at home. For example, chairs, windows, curtains, etc. You can also find patterns in several objects. Geometrical shapes, sounds, physical actions such as clapping or jumping. We can also make patterns with numbers. In this video, we will see a pattern made with numbers. Let's look at this number strip. It has some blank spaces. Can you fill in the correct digits? If you notice, then you will see that every succeeding term is obtained by adding 3 to its preceding term. If we follow the same pattern or rule, then we can easily fill these blank spaces and complete this number strip or list. Let us see this number list. Do you see any pattern here? Yes. Here, the next number is obtained by adding -5 to the previous number. We can also fill the empty spaces in this list by following the same pattern or rule. What can you tell by looking at these two patterns? We see that each term in this list, except the first term, is derived by adding a certain number, which is 3 here, to the previous term. On the other hand, every term in this list, except the first term, is derived by adding a certain number, which is -5 here, to the term before itself. Such a list of numbers, where each term except the first term is obtained by adding a certain number to the previous term, is called an arithmetic progression, AP. And the fixed number that is added is called the common difference of the arithmetic progression, which we represent by the letter D. This is called the general form of the arithmetic progression, where A is the first term of the progression. Will the common difference of an AP always be positive? Always remember that the common difference of an AP can be positive, negative, or 0. If the first term of an arithmetic progression of n terms is written as A1, second term as A2, third term as A3, and moving in the same order, if we write the nth term as A minus n, and if we write the common difference as D, then it becomes an AP. If we observe these lists here, which are AP, we see that every AP has the last term, that is, the number of terms is fixed. Such an AP is called as the finite AP. And an AP without a last term, that is, the number of terms is not fixed, is called an infinite AP. Today in this video, we learned about arithmetic progression and its components. In the next video, we will see some examples based on this. Welcome to this video. In the previous video, we learnt about arithmetic progression and its components. Today, we will see some examples based on this. Which of the lists given below is an AP? Can you tell how to find this? We learned in the previous video that in an AP, except for the first term, each term is found by adding a certain number, that is, the common difference D to its previous term. Therefore, the list in which any two consecutive terms will have the same difference will be an AP. If we look at the first, the second, and the third list here, for each of them, we get the same difference between every two consecutive terms. Hence, these three lists are an AP where the first and the third are finite APs and the second is an infinite AP. On the other hand, because the difference between every two consecutive terms in the fourth list is not the same, hence it is not an AP. Let's look at one more example. Rahul walks 3 kilometers on Monday and increases the distance covered in this way till Friday by 2 kilometers every day. Can you write a list for the distance travelled by Rahul every day? As per the question, Rahul travels a distance of 3 kilometers on Monday. Because he increases the distance travelled by 2 kilometers every day, the distance travelled by Rahul on Tuesday would be 3 plus 2 is equal to 5 kilometers. Thus, the distance travelled each day can be found by adding 2 to the distance of the previous day. What do you notice when you look at this list? This is also an arithmetic progression because here each term except the first term is obtained by adding a certain number to every term. And the number of terms in this series is fixed, hence this is a finite AP. Today in this video, we saw some examples based on AP. In the next video, we will see what kind of mistakes one commits while solving these types of questions. Welcome to this video. In the previous video, we saw some examples based on arithmetic progression. In this video, we will see what can be the common mistakes while solving these types of questions. Which statement is true for the given series? Pause the video to solve the question and then match your answer. Can you tell me what is the common difference? The difference between any two consecutive terms of an arithmetic progression is called the common difference. So, let's find the common difference of this series. If we find the difference between any two consecutive terms, then you will see that the difference between any two consecutive terms is not the same in all the cases, because of which this will not be an AP. Hence, option 3 is the correct answer. If you have chosen the first option, then it is a good try. But it's the wrong answer, because for the given series, you have found the common difference for the first 3 consecutive terms and chosen option 1 as the correct answer, which is not correct. If you have chosen the second option, then it's a good try. But this is also an incorrect answer. Can you tell what was the mistake committed while solving this question, which led us to choose the wrong option? For the given series, the common difference for only the first 3 consecutive terms was found. There too, instead of subtracting the previous term from a given term, we subtracted the next term from the previous term, which gives the common difference as 3, and that is a wrong answer. Let's see one more example. The depth of a river is 3 feet up to the first kilometer, and then with every kilometer, its depth increases by 10%. Will the obtained series be an arithmetic progression or not? Pause the video to solve the question and then match your answer. Let us first write a list for the given situation. According to the question, the depth of the river increases by 10% with every kilometer. That is, to get each term except the first term, 10% of the previous term must be found and added to the same. This is how we get a list. Is this an arithmetic progression, that is an AP? To check this, we will have to discuss the common difference of this series. When we find the difference between the 2 consecutive terms of this series, we find that this difference is not the same. Hence, this series is not an arithmetic progression. So, option 2 is the correct answer. If you have chosen the first option, then it's a good try. But this is an incorrect answer, because you have considered a 10% increase in the depth for every kilometer in the question as a fixed number. You remember that the series you get by adding a certain number to each term except the first term is an arithmetic series, due to which you considered 10% as a fixed number, and the series obtained according to the situation given in the question as an arithmetic series. And your answer went wrong. Teachers can check the understanding of the students in the class with the help of some such examples. Welcome to this video. So far, we have read about arithmetic progression and its components. Today, in this video, we will learn to find the nth term of an arithmetic progression, that is AP. We are given 2 categories here, where the first term of the first category is 3 and the common difference is also 3. And the first term in the second category is 26 and the common difference is -10. If we observe the first AP, the number of terms is fixed. Such an AP is called finite AP. And the second AP does not have the last term, that is, the number of terms is not fixed. Such an AP is called an infinite AP. Let us assume that A1, first term, A2, second term, A3, third term, A4, fourth term, one AP whose common difference is D. Here, first term A1 can be written as A plus 1 minus 1 multiplied by D. The second term A2 as A plus 2 minus 1 multiplied by D. The third term A3 as A plus 3 minus 1 multiplied by D. And the fourth term A4 can be written as A plus 4 minus 1 multiplied by D. Proceeding in the same order, we can express the nth term of A2 as A plus n minus 1 multiplied by D. It is the nth term of AP where A is the first term and D is the common difference. Here, AN is called the general term of an arithmetic progression. If there are m terms in the AP, then AM represents the last term, which is sometimes also denoted by L. Let's see an example. In a school ground, there are 35 students in the first row, 30 in the second row, 25 in the third row, etc. It has 5 students in the last row. How many rows of students are there in the school ground? Let the number of rows be n. Then, the first row, that is the first term A, equals 35. The common difference of the row D equals minus 5. And here, the last term, that is AN, equals 5. We have to find the number of rows of students. Therefore, we have to find the value of n. Can you tell me how will we do that? Well done! Looking at the pattern formed above, using the general form of AP, we can solve the problem and obtain the value of AN to be equal to 7. Hence, there are total of 7 rows of students in the school ground. Today in this video, we learned to find the nth term of an AP. In the next video, we will see some examples related to this concept. Welcome to this video. In our previous video, we learned how to find the nth term of an arithmetic progression. Today we will see an example based on this. Gaurav took a rented house for 15 years. He was given this house with a monthly rental of Rs 5,000 and an annual monthly rental increase of Rs 500. What will be his monthly rent in the 11th year? The monthly rent for the first year will be Rs 5,000. Can you find the monthly rent for the second year? Well done! It is very easy. We just have to add the annual increase to the monthly rent for the first year. Hence, the monthly rent for the second year will be Rs 5,500. Similarly, we can find the monthly rent for the third year by adding Rs 500 to the rent of the previous year. Similarly, we can also find the monthly rent for the fourth year. Therefore, the monthly rent for the third year will be Rs 6,000 and the monthly rent for the fourth year will be Rs 6,500. If we observe carefully, we can see a pattern here. Can you tell me whether this is an arithmetic progression or not? Well done! This is an AP. We have to find the monthly rent for the 11th year. Now, Tell me, what will we do to find the value for the 11th year? Absolutely right. Now we will use the formula for the nth term, an, or the general term of an AP. Here, the first term A equals to 5000, the common difference D is 500, and N equals to 11. Therefore, the 11th term of the AP comes out to be 10,000. So, the monthly rent for the 11th year will be rupees 10,000. In this video, we learned to find the nth term of an AP with the help of few examples. In the next video, we will see simple mistakes that can occur while solving these types of questions. Welcome to this video. In the previous video, we saw certain examples based on finding the nth term of an AP. Now we will see what are the common mistakes one can make while solving questions based on this method. Deepak's father started giving him rupees 50 as pocket money in the first month of the year and then increased the monthly pocket money by rupees 10. If in the nth month his pocket money becomes rupees 260, then find the value of n. Pause the video to solve the question and then match your answer. You can see that here we have to find the nth month. From this example, we see that every month pocket money is increasing by rupees 10, forming a pattern with which we can obtain an AP. Hence, with the help of the information provided and using the formula for the nth term or general term, we can solve the problem. The value of n comes out to be 22. In this situation, we can say that in the 22nd month, Deepak's pocket money will be 260 rupees. So, option 3 is the correct answer. If you have chosen the second option, it is a good attempt. But this is the wrong answer because you interchanged the place of n and an in the formula for the general term while calculating the value of n. And based on the same, you substituted all the values in the formula, because of which your answer can be wrong. Here, we have to note that n represents the number of terms and an represents the value of the nth term. If you have chosen the first option, it is a good attempt. But this is also an incorrect answer. Here you have correctly written the formula for the nth term, but you replace the value of the first term with the common difference and the value of the common difference with the first term. And solving the problem by substituting those values in the formula gives you the wrong answer. So hopefully, you must have understood by now why in this example the third option is correct and the other options are wrong. Teachers can also test the students' knowledge in class with the help of such examples.
Welcome to this video. So far, we have learned to find the nth term of an arithmetic progression. Moving forward, today in this video, we will learn to find the sum of the first n terms of an arithmetic progression. Ravi puts money in his piggy bank every day. If he puts 1 rupee on the first day and increases the amount in the piggy bank by 1 rupee every day, can you tell how much money he will save in 10 days? For this, we have to make a list of the amount Ravi puts in his piggy bank every day. What will be the first term of the list? Absolutely right. The first term A will be 1 because he puts 1 rupee in the piggy bank on the first day. Because Ravi increases the amount by 1 rupee per day, he will put 1 plus 1 equal to 2 rupees in the piggy bank the next day. Going forward in the same manner, we will get an arithmetic progression, which represents the money Ravi puts into his piggy bank every day. Now we have to find out how much money Ravi puts into the piggy bank in 10 days. For which, we have to calculate the sum of all the terms of this arithmetic progression. We represent it by S, and it displays the sum of the first n terms of an arithmetic progression. We can denote it by equation 1. By writing the terms of equation 1 in reverse order, we get equation 2. The equations 1 and 2 represent identical values. By adding equation 1 and 2, we get S equals to 55. Hence, Ravi has collected a total of 55 rupees in his piggy bank so far. Now, we will discuss the process of adding equations 1 and 2 step by step. If we write the steps as follows, what can you say by looking at it? We can see that the number 10 shows the number of terms of the arithmetic progression. Number 1 in bracket is the first term of the arithmetic progression, and 10 is the last term of the arithmetic progression. Therefore, in this manner, we can find the sum of terms of a finite arithmetic progression. Now, if we consider an arithmetic progression of n terms whose first term is a and last term, that is the nth term, is an, so according to the above formula, we can write the sum of the n terms of an arithmetic progression in this manner. Can you tell the nth term of the arithmetic progression? Absolutely correct. It will be a plus n minus 1 multiplied by d, where d is the common difference of the arithmetic progression. If we substitute the value of an in this formula, we get this formula, which represents the sum of the first n terms of the arithmetic progression whose common difference is d. Today, in this video, we have learned how to find the sum of the first n terms of an arithmetic progression. In the next video, we will see some interesting examples based on this. Welcome to this video. In the previous video, we learned to find the sum of the first n terms of an arithmetic progression. Today, we will see some interesting examples based on this. The first, second, and third rows of a cinema hall have 16, 20, and 24 chairs respectively. If the number of chairs keep increasing in this order, how many chairs will be there in the cinema hall having 16 rows? Can you tell me what we need to do first in order to solve this question? Absolutely correct. First of all, we have to make the list based on the data provided in the question. According to the question, there are 16 chairs in the first row, 20 chairs in the second row, and 24 chairs in the third row. What can you say about this list? The first term in this series is 16. The second term is 20, and the third term is 24. Here, the difference of two consecutive terms is the same, that is 4, which is a common difference D of this series. Hence, this progression is an arithmetic progression. Well done! Can you tell the number of terms this arithmetic progression will have? As we know, the cinema hall has 16 rows. The number of terms n in this arithmetic progression will be 16. Now, what do we have to do to find the total number of chairs in the cinema hall? To know the total number of chairs, we need to find the sum of 16 terms of the arithmetic progression. And how can we do this? We saw in the last video about how we can find the sum of the first n terms of the arithmetic progression with the help of two formulas. Can you tell which formula we should use here? Because we know the number of terms and the common difference, we will use this formula here. If we knew the nth term of an arithmetic progression, then we could use the second formula. Moving further, we substitute the values of a, n, and d in this formula. On solving this, we get 736. Therefore, the cinema hall will have a total of 736 chairs. Let's look at another example. Find the number of terms of an arithmetic progression whose first term is 21 and the last term is 994 and the sum of terms is 71,050. As per the question, the first term of the arithmetic progression is a, the last term is an, and the sum of all the terms of the arithmetic progression is s, with the help of which we have to find the total number of terms n of the arithmetic progression. Can you tell what we need to do for this? Yes, here we have to use the formula for the sum of the first n terms of the arithmetic progression. By substituting the values of a, an, and s in the formula, we get n equals to 140. Therefore, there will be a total of 140 terms in the arithmetic progression. Today, in this video, we have looked at some interesting examples based on the sum of the first n terms of an arithmetic progression. In the next video, we will see some simple mistakes that can occur while solving these types of questions. Welcome to this video. In the previous video, we saw some interesting examples based on the sum of the first n terms of an arithmetic progression. In this video, we will see what are the common mistakes that can occur while solving these types of questions. The fifth term of an arithmetic progression is minus 9, and its 15th term is minus 49. Then what will be the sum of the first 21 terms of this arithmetic progression? Pause the video and solve the question and match your answer. The fifth and the 15th terms of the arithmetic progression are given in the question, and we have to find the sum of the first 21 terms of this arithmetic progression. Can you tell what we have to do? To find the sum, we need the first term a and the common difference d of the arithmetic progression. If we write the fifth term, that is a5, and the 15th term, that is a15, this way, then we get the questions 1 and 2. Subtracting equation 2 from equation 1 gives us d as -4. By substituting the value of d in equation 1, we get the value of a equal to 7. In this question, we have to find the sum of the first 21 terms of the arithmetic progression. In this case, n would be equal to 21. On substituting the values of a, d and n in the formula to find the sum of the first n terms of the arithmetic progression and solving, we get -693. Hence, option 1 is the correct answer. If you have selected option 2, then it is a good attempt, but it is the wrong answer. Because your attempt was based on the wrong formula for the nth term of the arithmetic progression, you made the wrong equation from the 5th and 15th terms. And solving it further, you got the wrong value for the first term a. Proceeding in the same order, you solve the equation by substituting the incorrect value in the formula for the sum of the nth term, because of which your answer was incorrect. If you have selected option 3, it is also a good attempt, but it is the wrong answer. Let's see how. You found the correct values and selected this formula to find the sum. When substituting the value in this formula, instead of an, you solve the equation with the value of a15. You forgot that we have to find the sum of 21 terms of the arithmetic progression. So it is not a15 in place of an. Instead, we have to find the value of a21, because of which your answer was incorrect. So hopefully, you must have understood why the first option is correct and the rest are incorrect. Teachers can also test the knowledge of students in class with the help of such examples.